In these notes, we're going to be identifying the greatest common factor, or GCF, of a set of expressions, and also looking at the grouping method for factoring a polynomial. So to factor an expression or polynomial is to rewrite it as a product of prime factors. And we'll use that, we'll use the GCF to do that. Now GCF is the greatest common factor and that is the highest number or term that will divide into two or more terms evenly. If you have variables with exponents, the GCF of variables is the smallest exponent of the common variable. You'll see an example of that right now. So we have these two expressions, 17a squared and 34a cubed. So first you want to look at the coefficients. We have 17 and 34. The biggest number that'll divide into both of those evenly is 17. And then for the variables, they both have an a, and 2 is the smallest exponent possible or present, so that is what the GCF is in a squared. So 17a squared is the GCF there. Now sometimes the numbers aren't as easy to look at and decide. You can use what's called prime factorization to find the greatest common factor. Let's try that here. So we have 18 and 36. We're trying to find the GCF. If you think about their prime factorization, which is splitting up these numbers into their prime factors. So 18 is 2 times 9, and 9 is 3 times 3. And so these are the prime numbers that make up 18 when multiplied together, 2 times 3 times 3. 36 is 2 times 18, which is 2 times 9, which is 3 times 3. So what these two numbers have in common is a 2 and 2 3s. And so if you multiply those together, you get the GCF. And in this case, 2 times 3 times 3 is 18. So 18 is the biggest number that you can divide evenly into both of those. Let's try example B. We have 18, 30, and 54. Now, if you know the factors of these numbers, you could probably do this in your head and just think about the numbers that go into them and what the biggest one possible is. But if you don't, you can always use prime factorization. Let's try that. So 18, as we just did, is 2 times 3 times 3. 30 is 2 times 15, which is 3 times 5. And 54 is 2 times 27, which is 3 times 9, which is 3 times 3. And now you want to look through all these prime factorizations and find the numbers they have in common. They all have a 2, they all have a 3, and that's it. That's all they have in common. So 2 times 3 is 6. So our GCF here is 6. 6 is the biggest number you can divide evenly into 18, 30, and 54. Let's go on to example C. We have 12 and 40. So 12 is 2 times 6, which is 2 times 3. And 40 is 2 times 20, which is 2 times 10, which is 2 times 5. And so in common, we have a 2 and a 2, and that's it. 2 times 2 is 4. So I know our coefficient is 4. And then we want to look at the variables they have in common. So they both have an a, and of the a's, the smallest exponent present is a 1, so that goes in the GCF. They don't both have an n, so this is it. 4a is the GCF here. Okay, now we have 3 more. Again, we have 14, we have 20, and 35. So 14 is 2 times 7. 20 is 2 times 10, which is 2 times 5. 35 is 5 times 7. So looking at these, they don't have a GCF. There is no number that they have. So these two have a 2, but 35 doesn't. 14 and 35 both have 7, but 20 doesn't. 35 and 20 both have 5, but 14 doesn't. So the numbers, the coefficients, don't actually have a GCF other than 1. So we have a 1 at the beginning. And then for the variables, they all have an A. And again, 1 is the smallest exponent present. They all have a B to the third power, so that's in the GCF. They don't all have a C, so that's it. So the GCF here is AB cubed, or 1AB cubed, but you don't really need the 1, so just AB cubed. So that's the biggest thing we could divide out of all three of those expressions. Now we can use this to factor an expression by sort of using the reverse distributive property and divide everything by a GCF. So for the first one we have 6x plus 18. Well, 6 is the GCF of 6 and 18. So we can divide both of those by 6 and we end up with x plus 3. So we're kind of going backwards through the distributive property. For example, B, we have 2x squared plus x. Well, if you look at the GCF here, they both have an x. And that's it. So we can take an x out, and we're left with 2x plus 1. And you can always check this by multiplying the x back through. 2x squared plus x should match the original expression. So that's a good way to check your answer to see if you got it right. Just multiply it back through. Example C, 3x squared plus 15x. Well, we can divide a 3x out of this expression. And what's left is x plus 5. 3x is the GCF here. Between 3 and 15, 3 is the biggest number we can divide both of those by. They both have an x, and 1 is the smallest exponent present, so that's why 3x is the GCF. And then just divide each term by 3x, and you end up with x plus 5. Let's try the next one. 3 terms this time. The first one has a 2, the other ones just have 1s, so we won't be dividing a number out. They all have an x. 1 is the smallest exponent present, so we're going to leave that just like this, and what's left is 2x squared minus x plus 1. So that is how we factor an expression by using a GCF. Find the GCF of all the terms and then divide every term by that GCF. And writing it in this way is writing its factored form, because we're writing it as a product of prime factors. We have a prime factor here on example A of 6 and a prime factor of x plus 3. And we write those multiplied together. There's also a method which is called grouping. And it works if you have 4 terms. That's important. So it has to have 4 terms. And what you do is pair them up and take the GCF of each pair. So let's look at this first one. And you may need to rewrite the expression to make it easier, but you shouldn't need to. So let's look at this first one. Let's first find the GCF of the first 2 terms. So we have 6 and 9. The GCF there is a 3. They both have an x, and 1 is the smallest variable. They both have a y. They don't both have a z. So this is the GCF. What's left after we divide that out, 6x squared y divided by 3xy. Well, 6 divided by 3 is 2. X squared divided by x is x, and the y's cancel out. Plus, now we'll do the next one. 9 divided by 3 is 3. The x's cancel, the y's cancel, and then we have a z left over. Now let's do the second pair. So we can take out a 2 from this. Okay, what's left? 4x divided by 2 is 2x. 6z divided by 2 is 3z. Now what should happen here after you do this grouping and take out a GCF, these two terms right here, these two expressions, should be the same. And you see here they are. They're both a 2x plus 3z. So this is the first part of our factored form. And the second part comes from what's left. We've got a 3xy plus 2. That's our second one, 3xy plus 2. And there is the factored form of that expression. If we went through and multiplied this back, 2x times here, 2x times here, 3z, 3z, you would find that you would get the original expression. And that's grouping. Let's try another one. So the first two terms, we can take out a 2y from that. What's left is x minus 4. Second two terms, 6x minus 24, we can take out a 6, positive 6. What's left is x minus 4. And again, you can see that these two terms are the same. So that's our first one, x minus 4 times what's left, which is 2y plus 6. The 2y plus 6 came from right here, 2y plus 6. So first two terms, take the GCF. Second two terms, take the GCF. What's left should be two identical expressions. That's one of your factors. The second one is what's left. Here, 2y plus 6. Okay, let's try the next one. First two terms, we have 2ax plus 6xc. We can take out a 2 and an x from both of those. So what's left here is a plus 3c. For the second two, we can take out a b from both the positive b, so plus b. And again, what's left here is a plus 3c. And you can see right here we've got a plus 3c on both of those. That's the first expression. And next is what's left, 2x plus b. There's your answer. Last one. So 6mx plus 4m, we're going to take out a 2m. And that's a 3x for the first term plus 2 for the second term. Now notice the negative signs here. We want to end up with 3x plus 2, and both of those are positive. So we're going to take out a negative, and it looks like we can take out a negative r from these two. So what's left here is a positive 3x and a positive 2, and that's what we wanted. We wanted that to be positive. So we have 3x plus 2 for our first term, and we've got 2m minus r for the second. And that is the method of grouping for factoring a 4-term polynomial. You need 4 terms, so you can group them into two pairs. But we're using a GCF, the greatest common factor of each pair.